Welcome to Lesson 7A, Confined Space. This will be a short module on confined spaces. There can be accidents and even deaths that occur when you have workers going into what we call confined spaces, and I'll show you some examples. Let me just list first some examples of what this might be. Anytime you have some kind of a large tank, and it might be at a chemical plant or something with some liquid that's evaporating, that's what we're going to primarily address today. A utility tunnel, like the famous steam tunnels at Penn State. A silo, you often hear about accidents in silos. The air in the silo on a farm can get very bad, poor quality air. A lot of carbon dioxide released by decaying corn or grain. People can get asphyxiated from that. A storage tank of some kind where you have to go down into it. Let's consider an example. Suppose you have a big round cylindrical tank like this. There's always some kind of an opening up here, but suppose that's closed, or even if it's open and workers can go in there, there's not a lot of air circulation. It's kind of stagnant air inside there. And let's suppose this has been sitting there with some kind of harmful chemical of species J in there. It's going to evaporate. Now we know that it'll keep evaporating until it reaches some kind of steady state. So the key here is that we're going to be talking about a case where a long time has elapsed. Therefore, the air is saturated with as much of J vapors as possible. And so this will start evaporating, and eventually up here you have air plus species J vapors. And the whole thing comes to equilibrium eventually. As long as you still have a puddle left, you have some liquid left, then we know it's come to equilibrium and it will stop evaporating because you can't put any more into the air. And so we're going to assume there is some liquid left in the air. This is kind of a review of what we've been talking about, how to estimate PJ in the air. What's the partial pressure, or from that you can convert to mole fractions, etc. We have four cases that we've already talked about. If it's a pure liquid, some VOC, then PJ will equal PVJ. Again, we're assuming there's some liquid left in the tank. We'll talk next time about different cases of that where you have certain kinds of liquids and conditions where it'll all evaporate, and then you evaporate all the liquid, and then that's how much is in the air. But we're assuming that it's reached steady state and there's still some liquid. So if it's a pure liquid, PJ equal PVJ. Number two, if it's not a pure liquid, but XJ is very small, then we use Henry's law. If it's not a pure liquid, but XJ is close to its maximum solubility in the water, then you use Raoult's law. And if XJ is in between, you need a table or plot or some kind of equation, a curve fit, to get that amount. What we're going to be interested in is when workers enter a confined space. And as I said at the beginning, this can be hazardous and it could even lead to death. I'm just going to show you a couple articles that I've collected over the years. This was back in 2000, and this was in our local Center Daily Times newspaper. And so I cut it out and took an image of it here. This guy, a young man, age 20, his boss made him go into this large tank back here. You can see it just like I was drawing, a large cylindrical tank, to clean out the tank. And it had some stuff in it that generated hydrogen cyanide gas. And he didn't die from it, but it affected his muscles, especially in his face. If you read the article closely, he can't move his mouth muscles and has this constant kind of stare, and he can't give expressions on his face anymore. It's hard for him to talk because of the muscle problems. That's a case where the worker didn't die, but his life was ruined by this. There's another more recent case that I found on the internet. This one was just a couple years ago. On a ship, workers had to go down into this kind of storage area, and they were asphyxiated. This is a case where somebody died from this, from asphyxiation. You don't get enough oxygen. And so if we read on, I have part of this article covered here, but it turns out that a test in the atmosphere in the tank determined that it was less than 6%, which is really small. Remember, normal oxygen is around 19 or so percent. The actual freon that he was breathing isn't very harmful to you, but when you displace the oxygen in there, that's what the problem is. You don't have enough oxygen, and this person actually died. This is what often happens in silos too with farming, that they'll have carbon dioxide in the silos. Workers will go in there and be asphyxiated, and someone else will come in to try to rescue them, and that person dies too. I've read articles where there's been several people dying in the same location for the same reason, and they were trying to help each other, but they didn't realize. So how do you avoid these kinds of confined space accidents? The best way, and if you follow all the OSHA rules, is to have a ventilation system. Here you can see a flexible tube, and off to the side is a fan that's blowing fresh air down into this manhole. This is some kind of a utility tunnel underneath, and then the workers go down in this ladder, and then they have a tripod, and you could see some cables where the workers will be attached to a harness from this tripod and go down. That helps both in case they slip on the ladder, or if anything happens and they pass out or something, that they can be pulled back up out of danger. I've seen this at Penn State. I took a picture one time, but I can't find my picture, probably on my old phone. They have a fan blowing, and there's a couple guys standing on top and someone down below, and they're in constant communication, and they're blowing that fresh air in there. That's how they should have done it to avoid these kind of accidents. They don't see anything like that in here. There's a harness, but I don't see any air blowing in. And then, of course, in this case, the guy just went in without any protection. Read the article. He didn't even have protective gear on. There's no quiz for this module. I just wanted to let you know a little bit about why this is a problem, and then we'll talk about more of the details and the math, thermodynamics of this next time. Thank you for watching this video. Please subscribe to my YouTube channel for more videos. 1, 2, 3.